Welcome. My name is Lauren Harder. I am a senior educational developer here for VEX Robotics, and I have Dr. Rika Carlsen here with us from Robert Morris University. She is both a biomedical and mechanical engineer. And we're going to talk a little bit today about engineering and her background in engineering and kind of how she got to where she is today in preparation for Engineering Week. So, Dr. Carlsen, what kind of inspired you to get into engineering in the first place?
Yeah, that's a really good question. Actually, when I was an undergrad student, or actually even before an undergrad student, when I was a high school student, I had no idea what I wanted to do in the future. But I did know that I enjoyed math and science, and those were my favorite courses. And also, I knew I wanted to do something that would make an impact on others. And so, it took me some time to really figure out what I wanted to do. But I went to college undecided my first year and kind of explored different majors and came across engineering, had a few friends who were studying engineering and realized, that really integrates all the different things that I enjoy doing, math and science. And so, and plus you can make a huge impact on others through, designing new engineering technologies and so forth. And so that's really, where I heard about engineering for the first time and didn't get much experience, as a middle school or high school student. And then, started majoring in it and really fell in love with it.
Awesome.
And
Now I know
continued.
that you were both biomedical and mechanical. So
Right.
what made you decide to kind of do both? And if you could kind of touch on a little bit for maybe somebody that's not familiar with, I guess, the ins and outs of each, if you could kind of describe both and then kind of what made you want to do both in the first place.
Right, right. Yeah, so it's one thing to decide to pursue an engineering degree, right? But there's so many different kinds of engineering. So trying to figure out which one you want to do in the future is also a challenge. And so, mechanical engineering is one of the broadest engineering fields. And so basically anything that's mechanical in nature, a mechanical system, is designed by mechanical engineers. And so, that was my initial focus since I actually didn't know what exactly I wanted to do. So I figured, well, why don't I major in the broadest field first, and then I can decide on which direction I wanted to go. In addition to that, I always had a love of biology. And so biology and medicine, but I knew I didn't want to go and become a doctor. And so, the biomedical engineering side of things integrates, some of those passions in the biology field and medicine. And so, biomedical engineering is the integration between engineering, biology, and medicine, right? And so you can pretty much go in any direction. So if you take any of those engineering fields and apply it to medicine, that's an area of biomedical engineering. So you can take mechanical engineering and mechanical engineering medicine, and that's an area of biomechanics. And so that's, one direction you could go. You could take software engineering and medicine, put that together, and you can do things like in bioimaging and analysis. Same thing, electrical engineering and medicine, you put that together and you can do things with, designing electrical components for prosthetic devices. And so, there's a lot of different directions you can go even within biomedical engineering. And so that really allowed me to explore that, passion I had with the biology and medicine and applying the engineering knowledge towards that. And so with, biomedical engineering, again, with my goal of trying to make an impact on others and help others, right, you can really see that direct impact of the work that you're doing. And so, that was, one of my reasons for focusing in that area.
For sure. I know that my background is in mathematics and also technology and teaching teachers and stuff like that. So I have a deep connection as well for wanting to help others, inspire others, and make a difference, not only for students, but for all the teachers that also impact the students. So I could definitely see that. And I know that engineering is everywhere. But as far as things that you've worked on so far in your career, do you have like a moment or two or a project or two that maybe you worked on that was really inspiring or rewarding for you?
Yeah, actually, what I'm doing right now is I find very rewarding. So right now I'm studying traumatic brain injury. And
Oh,
so
wow.
again, this is applying that, biomedical engineering knowledge, right? So that engineering knowledge towards medicine. And so when you think about traumatic brain injuries, you think about, how a person sustains that. That's from an impact to the head, right? So that could be a mechanical impact. It could also be exposure to like a blast load for applications in the military. So really understanding how, a war fighter might get injured in the head when they're exposed to a blast. And so that application of forces to the body, that's an area of where you're applying engineering knowledge to study, what happens to a person. And so this area of biomechanics, and especially injury biomechanics, so understanding how people might get injured and then how can we go about preventing that injury and treating that injury. And so this is a huge area of biomedical engineering. And so right now, what I'm doing in my group is we're developing computational models that allow us to visualize what happens inside the brain when a person, for example, has an impact to the head. And so we can actually visualize the deformations that happen in the brain. And then we try to connect that to what happens to the individual neural cells in the brain. And so that brings in all the biology, right? So understanding that process as well. So it's a, mechanics problem as much as it is a biology problem. And so trying to understand, the effective forces on the head, on the brain, on the cells, and then understanding how those cells might become damaged. And then, based on that information, can we develop, better protective helmets for individuals, or maybe change different protocols, maybe in a sports game, right, to prevent injury.
Yeah, I was
And
just
so we,
thinking that.
yeah, yes,
As you were kind of explaining, I was like, I wonder if this is similar to things maybe they do in the NFL or with concussions or something like that. So,
exactly. But yeah, a concussion is a mild form of traumatic brain injury, and so yeah, this work applies for understanding concussive injury as well.
oh, that's awesome. And I know that there's always a lot of questions of not just for me that I get sometimes from students about, well, what's it like to be in the math field and what do you do on a daily basis and stuff like that. So be able to hear that that's the kind of stuff that you're working on is
Hmm.
really awesome, because I think sometimes they just, we hear biomedical engineering, it's just like, oh, maybe it's just studying biology, but as you're kind of talking about these different projects and what you're working on, it's very everyday sort of instances.
Absolutely. And, you can do work like in basic research, right? So really understanding the fundamentals of how things happen, but also you can apply that research. And so, in this area, there's a lot of applications, right? So for example, helmet design. And so everything that we learn about how the brain might become damaged, we can apply that to develop, better helmets. And then you take things like materials engineering, so you can develop new liners for helmets, right? To absorb the impact, reduce, the rotational accelerations of the head, and apply all that information, to build something that's better, right? And then can affect everybody, right? Can have a huge impact on others, you know, based on helmets that they purchase for, riding a bike, for example.
Right. That's awesome. So I know that you also do this research as you're studying, but you're also teaching students as well.
Hmm.
What would you say? I'm not sure if advice is the right word, but is there something that you often say to your students or different experiences that kind of get ready to go out in this field, or even if they're just kind of coming in for the first time with a lot of knowledge in engineering? Is there something that you kind of coach them through or talk about it? Maybe different skills such as, oh, you're going to have to think about persistence or iteration. Is there
Hmm.
any sorts of things like that when you're dealing with engineering?
Yeah, so I mean, one of the things we learn in college with an engineering degree is how to solve problems, right? So that's really the essence of engineering, is being a problem solver. And so, in our classes, we gain that knowledge of how to go through any problem, whether it's like a worksheet, right? And you're given like a word problem to solve, or you're trying to come up with a new design, right? So, and you encounter certain challenges. So the more times that you work through that problem solving cycle and the engineering design cycle, the better you get at it, right? And so those skill sets you can apply to any area, even outside of engineering, right? Problem solving skills help, you critically think through anything. And so developing those skill sets are important. A huge thing too within engineering that people don't often think about is teamwork and communication skills. So oftentimes you're not working alone. Actually, most of the time you're working in teams. So you have people with different areas of expertise coming together to solve a problem. And so, developing those skills as well is extremely important. So I mean, in college, you often work on teams, on projects. And so you start to get some of that experience, but having leadership skills, interpersonal skills is important as you go and work in the field.
Absolutely. That's a really great point that you bring that up, because even with VEX robotics and kind of the stuff that we do here, it's not just about learning STEMs like technology or mathematics in isolation, but it's also about solving problems,
Right.
iteration, working together as a team. If I have an idea, how do I actually communicate that to others and
Exactly.
kind of work through that? So all of that I think kind of falls into engineering as well. So
Right, right, right.
awesome. Well, I think the last thing that we can definitely kind of address, or for anybody that's kind of thinking about getting interested in engineering, what do you think would be their first step for somebody that has no knowledge? Maybe they're in high school, maybe even a little bit
Mhm.
younger, and they kind of want to learn more about engineering. What would you recommend?
I think that, I mean, there's so many great programs out there, right? Even with, yeah, VEX Robotics, you were telling me some of the programs that you guys do. So just try to get some experience, get involved with some of the STEM programs that you see, whether they're offered by, your school, maybe a local college, and, just get some experience, see if it's something that you enjoy doing. Maybe taking some classes in high school as well that's related to the engineering field. And then also talk to people. So talk to, people like myself. I'm always happy to answer questions, right? If you send me an email, talk to students that that might be studying engineering right now, and just to learn a little bit more about the field would be my advice.
Yeah, I think that's a great point too, to reach out to an actual engineer,
Right, yeah.
actually ask them a couple questions, or even for someone that, if you're maybe in a collegiate setting or somewhere that you could just hang out with an engineer for a day and kind of
Mhm.
see what their day is like and the types of problems that they're faced with, I think would be really exciting as well, just to get a little bit more knowledge on what that really looks like.
Absolutely. And there's a lot of organizations too that offer programs like the Society of Women Engineers, for example. They have a SWE Next program. And so you can actually get involved as a high school student in the organization and get involved with some of their activities. And then you can also connect with actual professional engineers through that program. And
Awesome.
so, looking out, searching for some of these professional organizations that you can get involved with, even as a high school student, is a great way just to learn a little bit more, right?
Yeah, no, that's great advice for sure. Well, Dr. Carlson, thank you so much for your time. I know that we are both so excited for Engineering Week, and we can't wait to see what everybody kind of gets into and learns more about engineering as we kind of promote the career. So thank you so much, Dr. Carlson.
Absolutely. Thank you.